Hey everyone! Today, we're diving into Pakistan's incredible metal workshops, where ancient techniques meet modern craftsmanship. First up, watch as these artisans build a massive bandsaw entirely by hand. It all starts with wooden templates. These guides ensure every metal piece will fit perfectly later. Next, they heat steel until it glows red hot, then hammer it into shape, just like blacksmiths did centuries ago. Power tools take over now, trimming the metal with laser-like accuracy. This 5,000-year-old technique? Still the #1 way to make metal parts today. Sand molds can create huge, complex shapes in one pour, perfect for engines, ship parts, and more. Accounting for the majority of metal castings produced today. Workers pack special sand around the pattern, then pour molten metal into the cavity. After cooling, voila! A perfect metal copy. It is extremely important for large industrial components such as engine blocks, pump housings, ship propellers, and crankshafts. Try making a ship propeller with a 3D printer. Sand casting handles what modern machines can't. The ability to create neonet-shaped large parts gives sand casting a unique advantage in heavy industry. Metal shrinks as it cools, so patterns are made 2% bigger. Genius, right? At the heart of this process lies the ability to predict and control how both the sand and the molten metal will behave. This begins with the creation of a pattern, whose accuracy is essential for the entire casting process. (1,300°C) molten steel flows like syrup into the mold. One wrong move equals disaster. To compensate for this, patterns are intentionally made slightly oversized. This extra material, known as a contraction allowance, is calculated based on the type of metal being used. By adding this allowance, the final casting achieves the correct dimensions once it has fully solidified and contracted. After cooling, it's time for the big reveal, smashing away the sand to uncover the metal masterpiece inside. Skilled workers coordinate to tilt the ladle and guide the flow of liquid metal through the screw and runner system. Once the molten metal has fully solidified, the team starts separating the newly formed casting from its surrounding mold materials. Grinders buzz as workers remove rough edges. Every millimeter matters. In many traditional settings, the sand mold is dismantled by hand, sometimes with simple tools that help lift away the upper sections. The casting that emerges at this point typically still carries remnants of gating systems, risers, and any excess metal. The next phase typically involves removing unwanted material and refining the piece so that it meets the required specifications. Excess metal from runners, risers, or gating systems must be cut or ground away to reveal the net shape of the component. Micrometers measure perfection. Even a hair's width error could wreck an engine. Now serve no function in the finished product and can interfere with the component's performance if not properly removed. During this process, the casting is gradually shaped to match the engineering drawings or blueprints. The entire operation demands both technical know-how and close attention to safety. These could compromise its integrity or interfere with subsequent processes. The cleanup phase can also include smoothing out rough edges or irregular created during pouring. Chisels, hammers, and handheld grinders often come into play here. Particularly if the casting includes intricate geometries or tight corners that are difficult to access with larger machinery. Workers press-fit bearings with surgical precision. No computers, just skill. Workers begin by ensuring that the cast piece is properly aligned and ready to accept the screw mechanism. They carefully measure and mark the areas where holes need to be drilled or tapped. Then, they use a handheld power tool to create the necessary openings. Once the threaded rod is inserted, it is secured in place with additional fasteners or set screws, depending on the design. A hand wheel or turning handle is often attached to one end of the rod. This enables the operator to rotate it and move any connected parts along the rod's length. Before fitting them into place, the bearings are inspected for damage and lightly lubricated to ensure smooth movement. The housing is then carefully prepared so the bearings can sit securely and maintain proper alignment. Once a large cast plate has been produced, the next crucial step is to create a smooth, precisely level surface. This will serve as a stable foundation for the machine's operations. This often involves mounting the plate onto a planing or milling machine. Once there, it is clamped securely so that a cutting tool can traverse its surface. As the tool moves methodically across the plate, it shaves away thin layers of metal in the form of chips or swarf. After achieving a consistent finish, the plate is integrated into the main framework of the machinery. By combining a precisely machined surface with robust structural supports, the assembly gains both mechanical stability and alignment. This ensures that any moving parts, such as reciprocating arms or rotating shafts, will interact correctly with the blade surface. After a heavy-duty machine has been cast, machined, and assembled to the point where all moving parts align correctly. The freshly built structure is typically coated with paint to guard against corrosion and to give the machine a clean, professional appearance. As we see, even in regions where high-tech automation and limited traditional methods can build machines of remarkable durability and performance. Then, for the second project, the team will be working on a compressor crankshaft. As we see, despite the rise in automation and CNC machining, traditional crankshaft manufacturing remain relevant. In some industrial communities, knowledge of hand forging and manual machining has been passed down like cultural treasure. In this case, workers still forge and machine crankshafts by hand, using techniques and even machinery that are decades old. This more hands-on approach has been used for over 75 years and is still alive in well-researched places. The enduring practice isn't just nostalgia, it fills a practical need. Local industries benefit from crankshafts without expensive imported equipment. In these regions, traditional manufacturing supports industrial development by providing affordable, reliable parts. After cutting the steel, it is heated in a high-temperature furnace until it reaches the plastic deformation range. It often exceeds 1000 C, 1832 F, for most medium carbon and alloy steels. After the rough forging is complete, the now partially shaped steel is moved to a lathe or other machining equipment. Here, any excess material is removed, and bearing journals and shaft diameters are precisely cut to specification. Skilled machinists rely heavily on manual measurements and careful observation at every step of the process. They use precision instruments such as dial indicators, micrometers, calipers, and surface gauges. (1851). This way they can verify that each cut conforms to strict tolerances. For instance, as a cutting tool removes material from a forged crankshaft, the operator will frequently stop the machine to check it. During this phase, he performs visual tests of the diameter, roundness, and alignment of the workpiece. Even minor deviations in the order of microns can lead to imbalances or premature wear when the part is in service. This iterative process ensures that the surface finish is smooth and free from imperfections such as tool marks or burrs. Machinists are trained to read the behavior of the metal and the cutting tool. They observe the sound and vibration during cutting, which can indicate issues like chatter or tool wear. Their experience allows them to predict and correct potential problems before they affect the final product. But don't leave yet, as this has just started. Although in many cases they are dedicated to creating industrial material, they can also make a perfect hood. The process begins with the careful selection of raw sheet metal, typically high-quality mild steel or aluminum. This material is chosen for its durability, strength, and lightweight properties. The raw sheets are first inspected and then accurately cut to the required dimensions. This way, the team ensures that they contain enough material for subsequent shaping while minimizing waste. Next, the process moves into stamping and forming, where a large, manually operated press is used to transform the flat metal. During this phase, the sheets are transformed into the curved, aerodynamic shape of a car hood. custom-designed dies and punches, often created using time-honored methods, are employed. Skilled operators load the metal into the press, where immense force forces the sheet to conform to the die's contours. Manual oversight is absolutely essential during the stamping and forming process. Workers constantly observe the metal as it is forced into the die, watching for signs that the material is flowing uniformly. When they spot such issues, they quickly intervene by adjusting the press's alignment or modulating the force being applied. Following the stamping process, the rough-formed hood transitions to a critical phase. Excess material is removed and structural seams are refined, ensuring both functionality and visual appeal. In this stage, the byproducts of stamping, small ridges, flashes, and surplus metal that extend beyond the desired outline. Are precisely trimmed away using handheld cutting tools and saws. The operators, drawing on years of experience, carefully guide these tools along the contours of the stamped hood. Their objective is to remove only the unwanted material, preserving the integrity of the stamped shape. In parallel, they must leave behind a clean, accurate outline that will serve as the foundation for the subsequent assembly steps. Once the extraneous metal has been removed, the focus shifts to preparing the hood's edges and seams for welding. The seams, often the junctions where two metal panels meet, must be perfectly aligned. manual control exercise during welding is not only critical for achieving strong, consistent joints. Smooth, evenly laid welds contribute to both the durability and the visual appeal of the hood. Once approved, the hood is carefully cleaned to remove any residual from the manufacturing process. The component is then typically coated with a thin protective layer, such as a corrosion inhibitor or clear sealant. As we have seen, despite the lack of modern technologies, in Pakistan they know how to work perfectly. They are aware of the materials they work on, so they can craft huge industrial equipment parts with no problem. Large blocks of steel or iron, often sourced locally or from recycled scrap, are carefully inspected for quality. Traditional cutting methods, such as oxyfuel torches or manual shears, are employed to slice these hefty blocks. They are turned into pieces that can be handled by the available forging equipment. Once cut, the metal is heated in furnaces that have been in use for decades. These furnaces, often powered by coal or oil, are capable of reaching temperatures high enough to make the metal malleable. They begin by arranging bricks to define the mold's outer boundary. Then they carefully pack and shape sand inside this enclosure to create the precise negative form needed. Each section of sand is meticulously contoured to ensure accurate dimensions. Small holes or vents may be added to allow gases to escape once molten metal is poured in. This process is crucial because the quality of the sand mold directly affects the final casting. A well-compacted, accurately shaped mold helps prevent defects and ensures the metal flows evenly. Also, it maintains the correct geometry of the part. In such large-scale industrial production, this traditional approach remains indispensable. It offers a flexible, cost-effective method for creating massive, uniquely shaped components. These, otherwise, could be challenging or prohibitively expensive to fabricate with modern high-tech equipment. By relying on local materials like sand and bricks, foundries can construct molds of virtually any size or geometry. Moreover, as we have seen through all the last projects, human skill and experience lie at the heart of this approach. Workers who have spent years mastering the nuances of sand casting can adjust the mold's design on the fly. Their expertise is crucial in preventing common casting defects, such as gas porosity or misruns. These could undermine the structural integrity of the finished component. By keeping the casting and manufacturing process local, communities retain revenue. They also create and sustain jobs for mold makers, forgers, machinists, and other specialized roles. But beyond the economic advantages, this approach preserves artisanal knowledge. This includes the intuitive understanding of sand composition, mold design, and manual metalworking techniques. In an era where automation can diminish human involvement, these skills remain invaluable for addressing unique casting challenges. Consequently, despite the availability of cutting-edge manufacturing methods, traditional sand casting continues to be a cornerstone in large-scale industrial production around the globe. It provides a dependable, cost-effective, and adaptable solution for crafting heavy, complex parts. Once the casting process is complete, finishing huge industrial parts becomes a critical phase. As we saw with other similar processes, the component is trimmed to eliminate any extraneous metal. A misstep in this stage can lead to dimensional errors, which would then necessitate additional corrective machining. By meticulously eliminating the extraneous metal, the component's profile is refined to closely match the intended design. Thus, it provides a cleaner, more uniform base for the subsequent finishing and machining processes. Finally, the finished industrial part undergoes rigorous quality control and inspection. Once approved, the part is often coated with protective finishes, such as anti-corrosion treatments or paint. Through all these different processes, Pakistan demonstrates that its workforce is something more than just an industry. Check out Pakistani Hands channel for more mind-blowing projects. And don't forget to like, subscribe, and hit that notification bell for more amazing content.